and what you know, and if that doesn't reach all the way down to the people who really don't understand that crap which you have learned entire life, there is no point, okay? And science is something like that, exactly, which is for solving the problems, right? For the societal problems, the challenges we are facing. So you all are young scientists, right? And I urge you, whatever you learn, at least share it with your grandparents, parents, the children in the family, and you will learn that it's not too difficult or too hard to communicate the complicated stuff in a simple language, okay? And that's why Poorva is here, okay? She does exactly this. She tries to take complicated scientific, phenomenon like insects and plant interactions to the farmers, to the local people, and then try to convince them that we can live with them with harmony, okay, and within very good relations. Okay, so Poorva is a backyard beekeeper based out of Ahmedabad. She started exploring the world of bees by keeping native bee boxes in her garden 5 years back after training with UTMT. That's a very interesting organization based in Maharashtra under the mango tree. And they do lots of interesting projects in Madhya Pradesh, Gujarat, and Maharashtra. So she has come to develop a great appreciation for bees in particular and pollinators in general. Her venture, Bees in My Backyard, aims to create more awareness about bees, promote the use of native bees in apiculture, and curate quality bee industry products from beekeepers following beekeeping best practices. And along with Serenity Library, she is simultaneously working on raising awareness about pollinators around us and the need for pollinator-friendly planting through an venture called Nectar Navigators. She will be taking 2 sessions. The first is around more like theory. She will introduce you with some interesting honeybee species. And then following that, we have 2 interesting workshops. The demonstrations, one on the left side and one on the right side. I don't want to reveal the secrets. Okay, so just go through with this first 30 minutes, and this will be fun. Yeah, she will convince you that you can make complicated scientific, the mechanisms very easy in very simple language. Poorva, please.
Hi, everyone. My experiences of 5 years is what I've tried to bring out over here. I started working. My aim was to work with native bees in India. The most commonly used bee in apiculture across the world is Apis mellifera, which is the Western honeybee. And I really wanted to work with native bees in farms over here. That is how I reached out to Under the Mango Tree. And you can hear me? Okay. All right, so I started working with 2 different native bees in India, Apis cerana and stingless bee. We all know the role that bees play in the world, very important pollinators. You're all familiar with insect morphology, so I'm not going to get into too many details, but there are a couple of points which I'm going to point out over here. One is the fact that they have this tongue called a proboscis, which they use to suck nectar from flowers. Bees are actually classified based on the length of the proboscis as well, long-tongued and short-tongued bees. The other aspect which makes them really powerful pollinators is the presence of hair on their legs. And they have something called pollen sacs, where they actively collect pollen and take it to their hives. So bees are essentially collecting 2 things, nectar and pollen, and they use both of them within their hives. That is for the social bees. There are about 20,000 and more bees in the world. More than 90% of them are solitary bees. They live underground or they make homes inside bamboos, open wood, dried wood. And they use the pollen and nectar as well. They may not make as much honey which we can extract. So the one that comes to our mind usually is the European honeybee. When I say a bee, what we picture is a brown, black, striped insect living in a hexagonal hive. So we're going to start today with that. If you have any questions, anything to say, please ask, because I'd like it to be as interactive as we move along. So we have been using honey for a really long time. This is from a tomb in Egypt. So this is actively they're collecting honey from a honeycomb, and honey pots have been found in King Tutankhamun's tomb as well. And actually that honey has been found fit to consume. The ancient Greeks used it as well. Honey is known as a food for gods. It's called the ambrosia. It was supposed to give them long life. There are stories how they used all parts of the bees to make this ambrosia, and that is what really gave gods the extended lifespans that they had. There's also a story about how Zeus was protected by bees from his father, because Zeus was proclaimed to be the king, and the father was constantly going around killing all the infants, but it is the bees that protected him in the cave. So we come now, these are all images of Apis mellifera going forward that we will be looking at. When we talk about a beehive, it is a single unit. We're looking at hexagonal cells over here made of beeswax. Now, there is a hierarchy. There are 3 different types of bees inside a beehive. There is one queen, there are some drones, and there are multiple workers. The queen is about 2 to 3 times the size of a worker bee. That's the queen there in the yellow. And the queen's only role is to lay eggs. The queen chooses to lay fertilized eggs or unfertilized eggs, and it will always have a small group of worker bees who are walking around it to make sure that it's well fed and taken care of. It also obviously keeps the hive together by secreting pheromones and giving the signal to the workers to be there. The drone is the male bee. The only role of the drone is to mate, and it unfortunately dies after the nuptial flight. So a virgin bee, when it emerges, queen bee, when it emerges from the hive, it will take a flight. And that is when the drones from that hive and from around will fly out. They will mate in air, and then the queen comes back, and the drones all die. The queen is now ready for its 2 to 3 years lifespan of laying eggs. The third, and not the least, but honestly the most important, is the worker bee. The worker bee, again, is a female. It's got the mated chromosomal composition of XX. And the worker bee does everything inside the hive. It's the largest number. It's the one that moves out. It's the one that actually even controls when a new queen will come or not. So let's briefly look at what's happening inside a hive. Do we want to switch off the lights, or is the clarity clear? Yeah, maybe. Maybe just the top one here, so that, is it clear for everybody, the visual? Because there'll be lots of images and videos coming up. Okay, perfect. So this transparent, translucent little rice-like thing that you're seeing inside each hexagonal cell, that's an egg. It's about the size of a rice grain, and it's laid slanted by the queen. The queen comes in, it inspects the cell. If it finds it clean and ready, it will come in and it will lay an egg in it. And then that's it. That's when the workers come in. The first 2-3 days, the workers will give it royal jelly. Can you see, sorry. Can you see this creamish colored fluid here alongside the larvae? That's royal jelly. So each of these eggs is going to get a little bit of royal jelly, which is like manna. The queen is only fed royal jelly. So you can see the difference in the diet. The queen lives 2 to 3 years, while workers live about 5 to 6 weeks. Next stage is larva. You can see 2 stages over here. There is the smaller one with some royal jelly inside, and the larva size has gone up. Can you see the creamish colored liquid here? That's royal jelly. And then as the larva advances, the worker bees keep looking after it. They keep feeding it food, which is honey and bee bread made of pollen. And then once the larva has reached the right size, they're going to cover it with a thin layer of beeswax and let it pupate. Here's a very interesting video which shows the entire thing. Can we play the video, please? With the sound.
Here is a bee egg as it hatches into a larva. Those newly hatched larvae swim around their cells, feeding on a liquid food that nurse bees secrete for them. Then their head and their legs start to differentiate as they transform into pupae. Here's that same pupation process seen from above with varroa mites running around in the cells. Next, the tissue reorganizes in their body and the pigment slowly develops in their eyes. In the last step, their skin shrivels up and they sprout hair. Here,
so we've seen to the point where the worker bees have emerged, or the drone, from the cells. Now, after that, if you look up at top, there's a significant division of labor inside the beehive. It's really amazing how they function. They start with the worker actively cleaning the cell it has come out from. And Marie Kondo's its home. And after that, it moves on to become a nurse bee, where it's looking after the other workers, the larvae that is developing. Remember, they said that the nurse bees manufacture royal jelly and feed it to the larvae. So they're doing all of that at this point of time within a couple of days of coming out of the hive of their cells. Then they start working with the bees who are bringing in food from outside. What is the food? Nectar and pollen, right? Now, bees have a special stomach for the nectar that they bring in. And they pass the nectar, which is in the process of becoming honey, to another bee when they come inside the hive. Now, this worker bee over here takes it, processes it again in its stomach. And that cycle happens between 2-3 bees till it's ready chemically to be put down into the cells for storage. That's happening here. So these are all over a period of time and based on the age of the worker bee that the distribution of work happens. After the honey, part honey has been put inside the hexagonal cells, chemically it is honey, but for honey to have the longevity, the water content has to go down significantly. And for that, the bees, worker bees, will flap their wings to increase the temperature so that the water evaporates. Once that is ready, they're going to seal it with a beeswax layer. Beeswax is hygroscopic. It doesn't allow water to move around. So it maintains the water content at that level. After that comes the stage where they're actively working in construction inside the hive. So they are developing from their abdomen beeswax, which they use to extend the hive, to seal hive, to take out parts which have become black. Over a period of continuous use, white wax, which is how it originally starts, it will become lighter yellow to darker yellow to orange to brown to dark brown. So today when you see a hive, you can try and assess how old that hive could be. And they constantly need to replace it because beeswax again has antibacterial properties, and those properties go down over a period of time. So the chance of the hive getting infected and not being able to fight a pathogen increases. At this point, now finally having done all the inside hive duties, they are ready to go out. This is the only time at which now they can actually go out and forage for nectar and pollen. One of the toughest jobs, in my opinion. And after that comes the undertaker duty, where they have to clean the hive, take out the dead bees. If there is a predator, they have to address that. And most of the times, if the bees know that they're going to die, they actually move out of the hive and die outside. They will not die inside. So it's a very, very compact, intelligent unit that is working together. And that is why Johannes Mering, in the 19th century, himself an apiarist, but also a cabinet minister, chose to call a bee, he said, cannot be called an insect. It has to be a vertebrate, because a bee colony is a single being equivalent to a vertebrate animal, where all the workers together work as different organs inside a vertebrate. The queen and the drones take care of the reproductive aspect. Am I clear? Any questions so far? आगे नहीं जा रहा. So I'd mentioned the stomach, the honey stomach being separate, where it processes the nectar, comes back, takes it out. That is why sometimes some people say, कि, oh, honey is bee barf or bee vomit, because one bee is actively regurgitating it and giving it to another. There's also the stinger, which is a very interesting. We know that bees attack and they sting. In case of the queen bee, because the abdomen is enlarged, and in order to hold the eggs, it doesn't have a stinger. The drones don't sting either. The worker bees do. It's a kamikaze for them, because when they go out and they sting you, the stinger is barbed over here. So when it comes into your skin, it gets stuck there. And with it, it pulls out part of the abdomen of the worker bee. This here is the venom sac, which pulsates. So once the stinger is inside you, the venom sac will keep pulsating and pushing venom inside your fingers. So the best way to remove a stinger would be actually to scrape it out and not to push it and pull it out, because then you're actively squeezing all of the remaining venom in the venom sac into your skin. All right, this is just, I love this picture for the clarity with which you can see the nectar droplets in a lychee flower over here. That is what the bee would be collecting. Can you play this video, but on mute, please? So this is the proboscis that you can see sticking out, and the bees are sucking in the honey from a beekeeper's fingers over here. These are mellifera, very, very calm. You can really play with them, and actually they sense how calm you are as well. So even with the Apis cerana, the native Indian honeybee, the Asian honeybee, you can do the same if you are calm enough. That's pollen. You can see different colors in it, because different flowers will have different colored pollens, and bees actively mix it with nectar or honey and make what we term as pollen bread. Bee bread, sorry. Again, bee bread is something which is fed. It is a great source of protein. And bee bread is what is fed to the workers and to the larvae in order to grow. Pollen is also sold in the market because it's supposed to be a high source of protein. Okay, can you play the video, please? This is just to show you the pollen sacs. Can you see the yellow pollen on the hind leg? That's the pollen sacs filled with a lot of pollen in it. which they're actively going to go inside and empty. Now, as a beekeeper, you can have a small separator in front, which pushes that pollen out of their legs before they enter the hive. And that is the pollen that you will collect and which you see in the market. Now, bees for communication, we know pheromones as an active form of communication between insects to keep the hive together. The other very interesting one which bees do is called a waggle dance. Now, waggle dance, like we discussed the division of labor, bees foraging bees will go out. So today when I move a colony from one place to the other, or say if a bee finds a particular place not conducive for their growth, they will fly away, swarm off to another area. And over there, when they find a new place, the foraging bees, few of them will go out looking for food. Now, when they go out, they come back and they need to communicate the source of food, because finally in our world, everything is about efficiency, right? You want to have the best source of food available where you are spending the minimum amount of time and getting maximum out of it. So the bees that come back, they perform a waggle dance where they do a number 8. They do a zigzag in a straight line, and then they move around, and then they come back and do the zigzag, and then they move around and complete the number 8. Now, they do this with respect to the direction of the sun, so that the other bees who are observing them can understand from the beehive what is the direction they need to take to move out in order to find this particular food source. And how do they communicate that it's a good source of food? Anybody? It's the speed. Yeah. Sorry? Yeah, so it's the speed at which it does that. So the vibrations, how fast it is doing it, shows how excited it is about the food source and how fast it does the circle. And that communicates to the rest of the workers in the hive how fast they should move on. Can you play this video, please? Can you see the main bee doing the waggle dance here? There's the number 8 that it's forming, the zigzag and then the circles. There's obviously a couple of them following. Now, this is how they're exactly communicating. This is something which people are people are still studying. So hexagons. Anybody, any idea why hexagons? I think you all may have actually just studied this. I'm not sure if this is required over here at all. So like I said, it's about efficiency, right? How are they going to make the most use of the limited resources that they have, because they're spending their energy. Now, any given space, they need structural durability and they need to store their food, right? As well as have their brood. So we are looking at triangles, squares, circles. Circles we know will leave space. Triangle, squares we can make out largely. They will hold space together, and hexagons. 36 BC, Marcus. So this has been studied for a really long time. People have been contemplating, looking at it for a very long time. This may not be completely accurate, but this is a great visual to kind of understand the problem. They say about 12 worker bees lifespan worth of work gives you about a teaspoonful of honey. Okay, very precious. 12 worker bees working the ass off to get 1 teaspoon of honey. 8 teaspoons of honey gives you 1 teaspoon of beeswax. So they need to use their resource to make beeswax. Now, honey is also their resource for winters, for troubled times. It's also something which they're using as food actively for the hive. It's also something that they're using for construction, right? So this is a precious commodity for them. They need to use it as efficiently as possible. So Mr. Varro had 2 theories. They make hexagons because they have 6 legs, so it's easier for them to maneuver around hexagons. Second was that it's the most efficient shape. It gives you maximum area in minimum perimeter. But unfortunately, he couldn't really prove it at that time. This really got proven in 1999 by Professor Hales. This is known as the honeybee conjecture. And a hexagon, truly sufficient experiments have been done, and it's been mathematically proven that the hexagon shape gives you maximum structural durability and gives you maximum area for the least perimeter given. Hence, they're using the beeswax in the most efficient way. Any questions here? So beehive products, we practically use every single thing of it, every single bit. We use the honey, very clear how. We use beeswax. You've seen applications of beeswax. Can anybody give me some idea of where you've seen beeswax applications in real world? Sorry? Correct. Lipstick, okay. Lip balms, yes. Candles. Sorry? Stamps. Ah, those, correct? Correct, absolutely. So, okay, great. Great possibilities, right? Pollen. Any ideas? Okay, yeah. So it's a great source of protein. So the boxer, Muhammad Ali, he used to eat pollen. Abraham Lincoln used to eat pollen as a supplement in his food. Propolis. I haven't talked about propolis yet. What is propolis? Anybody has any idea?
Resins of the plants, that resins they collect from the plants, that is called as propolis or bee glue. Sometimes we call as bee glue. They used for like repairing their hive, and also it acts as glue. That's why
Correct.
it's called as bee glue.
Correct. Do you have anything to add to that, Anne? Correct. So you're right. It's plant extracts, resins that have been collected from the plants. They have also been processed by the bee further using honey. And it's very high on its antiseptic properties, extremely high. It's actually used as a mechanism by the bees to protect their hive. One very easy example. Today, if a big predator comes into the hive, which the bees can sting and kill, but they don't have enough manpower or muscle power to actively move it out of their hive, they are going to cover it with propolis. Because of its antiseptic properties, it will let that particular organism rot, but not allow pathogens to grow inside the hive. It's a very, very powerful agent, and hence it's used in the cosmetic industry and in medicines as well. It's also used in dental hygiene. When you get your RCT done, there is actually a propolis spray to take care of that specific area which has been dug into. Royal jelly. We talked about royal jelly, right? It's ultimate. I mean, you can see the longevity of the queen bee versus the worker bee, which is fed only royal jelly for 3 days, and the queen just lives on royal jelly. So royal jelly, again, for its longevity purposes, finds its use in cosmetics, in medicines, it's everywhere. Bee venom is used as well, medicine, right? So like you can see, we use almost everything. I won't be surprised if somewhere we make a bee chutney also. I've heard of ant chutney from Northeast, yeah.
Yeah, we discussed that ant chutney in the morning. Priyadarshan was brandishing it.
All right, so as much as I said I wanted to work with native bees, the entire example I've given you is of Apis mellifera so far. Now we'll move to some common bees which are from Ahmedabad around here. Maybe you'll be able to identify some of them. Maybe you've seen some of them. This is the carpenter bee. It's one of the many carpenter bees. Very obvious reason why it's called a carpenter bee. Would anybody like to venture a guess?
It makes its nest in the wood by cutting the wood. That's why it's called as carpenter bee.
Absolutely, absolutely correct. So, and again, this one lives in colonies, but it's not one of those which is going to have honey stored. It just has enough for its progeny. So we cannot extract honey from this particular bee, though this is found in colonies. So this is a eusocial bee in that sense. but not something from which humans can extract honey. Can you play that small video? Volume up कर देना इसका, अगर और हो सकता है. I don't think you could hear it. It's really loud. My kids used to call it the helicopter beat because you could hear it humming from far away. All right, this, for obvious reasons, is the blue-banded bee, a gorgeous bee, really pretty, metallic blue color. You can see it from far, not as big as the carpenter bee that we saw, a little smaller, but fatter. Solitary bee, found nesting in the mud. Again, something which if you look around now, if you have lantana bushes over here, you'll see a lot of it. It's really fast again. This is a cuckoo bee. Any guesses why? Yeah.
Yeah, it lays its eggs to another other bees nest.
Correct, absolutely.
And
Just
they-
like the cuckoo bird. It takes over other, doesn't do the mehnat itself, it takes over other bees' nests. Again, something you'll find very easily around here. This is from Serenity Library, this specific image. This, I don't have a good image. It's a very fast bee. I've seen enough of it, but unfortunately I had to put a cartoon over here. But that is the image of an actual leaf which has been cut by a leaf cutter bee. It uses the leaf cutter and almost rolls like a cigar kind of nest with it to lay its eggs inside. This is a different category. Again, lots of different bees in it. This is a common name, sweat bee, but if you go down to it, you can actually ID it very specifically to which one it is. You can see the one on the left has black and white bands on it. That obviously is not a bee. And this one is a bright metallic green, but also a sweat bee. Now we come down to apis, the most seen, understood, familiar bees. Any idea what this one is? Anybody has seen this? No, this is not. It's smaller. It's almost 1/3 the size of a Dorsetter. No, the third one still. But good guesses. Anybody else? They know it. Sorry? It looks big, but okay, we'll have a comparative one, I think, later on. But if you see, just pay attention to the bands in it. It's got a very bright orange on top, and then it has very clear black and white bands in it, right? This is Apis florea, the red dwarf bee. Okay, so this is smaller. This one is Apis cerana, the next up in size. You can see the difference in the banding between the two. Paron's got, it's like a fuzzier mix. Can't really make out where the black, cream, and browns are blending in. And this, so this Florea is slightly smaller. In this, the Cerana and Florea appear almost similar, but Florea is a little smaller. And that is Dorsetta, right? So to give you some reference of what you may have seen of these bees, Florea is something you'll really encounter a lot on flowers in the gardens around here. As will you see Dorsetta very easily. Dorsetta is also the bee whose big hives you see hanging from apartments, those huge ones which are very easily identifiable. Florea and Cerana, on the other hand, will make its hives in closer covered areas. Those are not ones which you'll see hanging from open spaces. So the red dwarf honeybee, the Indian honeybee for common name, and the giant honeybee. This is my particular favorite because it's really calm and nice, is the stingless bee. Over here, for comparison, you can see that's the stingless bee with pollen in its legs. And this is Apis florea for size comparison. It's really tiny. It's called the stingless bee because it doesn't sting. Its stinger is modified. Any idea on how it may protect itself if it doesn't sting? And that is the primary methodology for bees to protect themselves and their colonies. Sorry? It bites. It will actively come and bite you, and it plays, again, kamikaze, but of a different type, where it actually just comes in, it finds different orifices, nose, face, ears, mouth, and they'll just come in big numbers. Once they sense you as a danger, they'll alarm the rest of the colony, and they'll all come and they'll try and harass the daylight. They'll get in your hair. They'll just make sure you cannot hang around there anymore. So that's their mode of defense. Also, their colony is not exposed at all. I'm going to try and locate one on campus. I'm quite sure there is, and I will let Harshad know about it. You should go and take a look at it, because you really can't make out from the outside unless you know what you're looking for, that there is a bee colony inside. It has a very tiny tunnel up front of its hive, and the rest of the hive will be either in a brick wall or inside a tree trunk, where all of it will be there. It likes absolutely dark spaces, cool spaces, and that tunnel entry is the only thing. And they'll be in that tiny, about 2 centimeter wide tunnel hole. There will be 8 bees sitting around it, ensuring that nothing can enter it. So tiny, but not meek. Okay, so this is the view of a stingless bee colony. First and foremost thing which jumps out at anybody over here is there are no hexagons. Can you see these brown structures? They're all pots. There is no hexagon inside a stingless bee colony. Can you play the video, please? These are all stingless bees, workers, same concept. There is a queen, there are some drones, and there are lots and lots of female workers who are constantly working away. These bees are filling in pollen. Everybody can make that out. The yellow solid thing that they're putting in is pollen. So these are all pollen pots. These pots are not made of wax. They are made more of a propolis kind structure where it's more resin. So it doesn't have the same chemical constitution as beeswax. It makes similar pots for storing honey as well. Once one pot is full, it's ready, they will seal it completely. It makes, can you see the pollen there on its legs, on the hind legs, in the pollen sacs? It's going to empty that. See, actually emptying out its pockets. And there it's gone out. I love this video. I'm going to move my pointer, just observe. There will be a queen, again, significantly bigger in size. Same concept, it's going to go and inspect the cell. Now, the cell in which the egg is going to be laid are much smaller than the pots in which the pollen and the honey was being put. So the queen is going to walk around, she's going to inspect, and then observe it carefully, she's going to lay an egg. It's a very cool video. Okay. First, let's find the bee queen. Can you see this one? How much bigger it is with a swollen abdomen? Those are the workers cleaning up the cell, making sure everything's looking good. And there she's inspected it. There she's laying the egg, and off she goes. Job done. So thank you.